sorry, I forgot this. There's one resistor here. What's the value of this resistor? You asked the cross. What is it? 1K. All right, so I'm going to talk. First, I want you to take a look at it, make sure you understand the topology, and then hear me. Now, the critical thing in doing this is determining the voltage at one of these two input terminals. Because if you have the voltage on one, you have the voltage on the other. Everybody agree with that? That's the key thing. Now, if you look here, you can ground it here too, but that's 0 volts in the output is taken with respect to ground. This particular circuit here will not in any way, shape, or form give you the voltage here unless you know the voltage here beforehand. Do you all hear me on that? So in this case, this part of the circuit is almost worthless. As a matter of fact, it is worthless to find that voltage on the negative terminal, the input negative terminal. So you have to take a look at the other circuit, which is right here, the other connection. Now, this one is simple to do because you know no current can go in or out of that positive terminal. Does everybody understand that? So you can almost disconnect it, and I will, just to make the point. So if I wanted the voltage across that 12K right there with respect to ground, could it be found? Most people should be able to look at that and say, obviously, right? It's easy to find. That's voltage division, right? You got 1K in series with 12K and a source voltage of 12 milliamps. So I'll just call that V plus here would be equal to that 12 millivolts, right? And then it would be times 12K over 12 plus 1 or 13K. Does everybody agree with that? How many do? Let me see your hands because I want to make sure. Can you all see it far back? Okay. Now, you have that voltage here. And I'm calling it V plus, okay? Now, obviously, what's that? 144 over 13 millivolts. That voltage is here too. So this voltage now we know. Do you all agree? I just put a little extra to make my point. Yes, sir?
You chose the 12K because it's grounded on one side, right?
Yeah, but my real, yeah, that's true. You're right. You're mentioning something that's a very good point. The reason this part of the circuit will never give me any information, there's no way current can flow in that, there's no way to understand how to get the voltage at any part in the circuit. If it was grounded like, I would have to drop a resistor from here down to ground. Then you could work with that, but it's not that. It doesn't allow it. So what I'm looking at is how to get the voltage on one of these two terminals. I can get the voltage here pretty straightforward because I can see right here, there's no current in there. I can get that voltage with respect to ground. Does everybody follow me? That's my goal on this. All the voltages with respect to the ground. How many understand that idea? With me? All right, now, if I have the voltage here, which is, I'll call it V minus, and that's what, 144 millivolts over 13. The next obvious thing is, can I get any currents? Class, take a look. Reason it out. Yeah, I know the voltage here with respect to ground is 6 millivolts. I know the voltage here with respect is 144 over 13 millivolts. This current right there would be simply, I'll do it this way. This current I here is going to be, that would flow this way would be 6 millivolts minus, and this is going to be, I don't know what this number is, 144 over 13 millivolts, and it's all divided by 1K. Do you agree with that? I'm writing a little small. Can you see it in the back? So I'm going to divide that by 1K. Here's what I'm really going to do. I'm just going to get rid of that milli. And instead of having milli and K, they cancel, and this would be amps. Do you agree with this, class? Milli is 10 to the minus, I'm sorry, my bad. You're right, this would actually be times 10 to the minus 6, that's on me. You all follow me? Basically, milli is 10 to the minus third, K is 10 to the third. So 10 to the minus third, 10 to the third, 10 to the minus 6. Do you agree with that, class? How many do? I'm being looked at suspiciously. Trust me, it's right. Okay? Now, if I have this current right here, this is 10 to the minus 6 amps. I'm sorry, it's shaded right there. I'm just gonna put 10 to the minus 6 amps. I'm gonna leave it like that. So now the next point I'm gonna make is something I did last class. That current flows here. How much flows into the negative terminal? I'm gonna keep saying that until it's drummed in your head. 0, none. Where does the current go? It goes through this other resistor. That current right here will come around and up and go through here. So now we can get the voltage here. Do you agree with that? That voltage would be this current times 12K. I'll get that in a second. It's getting a little tough to write stuff there. The final voltage V out, I start right here, and I see I get this voltage at V plus, right? Then I have to do what? That's the voltage right here. I have to subtract this voltage from it. Now, indeed, this voltage, or this current might be negative, so you're effectively adding. Do y'all follow me in this? I don't know yet. Correct, class? But ultimately, that would be the approach. Start at the ground point, or 0 volts. Come to here, get V plus, then I would have to, I'll just find out what this voltage is. I'll call it V12. So what's V12 going to be? Well, it's going to be 144 over 13 millivolts, whatever that is. And then I'm going to take that current, which is, I don't even know what that is, but 6 minus 144. Oh, that's going to be actually negative, isn't it? Yeah. 13 times 10 to the minus 6, that's all right, we'll just do it this way. And then it's going to be times 12K, or times 12 times 10 to the third. And that will be the total voltage, I'm forgetting about, not V12, sorry, this would be V out. This right here would be the voltage on the 12K resistor right there. So this should be the correct answer. And do you all follow me the way I've approached this? How many understand that? Anybody have a question about anything I've done here? I'm just trying to get the final voltage in a direct form. Y'all with me? What is that voltage? Yes, sir.
Shouldn't it be 124 over 13 minus the volt V12?
Well, here's what I'm trying to do. I've got 6 millivolts here, right? And I need the current going that way, right? So it'd be 6 minus this, right? Didn't I do that right? I'm trying to get the current going that way, so it's the voltage on the positive minus the voltage on the negative terminal divided by the resistance. What I'm really trying to say is this. If you have a resistor R, and if these voltages are with respect to ground, and I have V1 and this V2, and I make this plus and minus, so I want this current I, it would be the voltage difference V1 minus V2 over the resistance R. Can you see it? Do you understand what I'm saying, sir? I mean, I'm just trying to be clear about that. That's how I got that. What's it? I mean, I know there's a negative. Look, I think this is, oh, I'm sorry. That should be negative. This is what you meant. I'm sorry. I think that's what you meant.
Yes, sir.
That was my bad. My bad. In other words, it's going to be a positive number there at the end of the day, because 6 minus 144 over 13, this is going to be negative, correct, class? Why don't I just correct it and do this? I'll put a plus here, and I'll put 144 over 13 first. Now, what's the total value of the output voltage? Yeah.
72.
72?
72.
How many did this one? Okay. Now, I'm showing you I'm trying to show you the logic, the reasoning behind everything, not just the answers, but this is how you get there. And the fundamental thing to look at is the voltage across one of those two inputs. I hope it answered your question. There's a question back there.
Oh, I was asking the same question.
Now, this is a great problem because everything, more or less, that can happen does happen here. You've got two voltage sources, right? You've got two different resistive bridge systems or different sets of resistors on both of them hooked to the different terminals. So you've got I call it complexity, but there's enough going on. So if you're trying to just memorize a template, oh, this is what it looks like, this is the answer, you're gonna hurt yourself. These things can take shape they can take shape so many ways. I got a question for you. What if instead of this right here, I'm just gonna modify one thing. Ready? Listen. What if I did this? Make this 12K and put a ground there. And yeah, I still want the voltage from plus to minus. Now think about it. Does it change anything at all from what I just did? Class, how many think it doesn't? It doesn't. Not one bit. That output voltage is never determined by this load, with one exception, if it's a direct short. And then the circuit would be it won't function, dysfunctional. Do you follow me? If this has any practical loading on it, or resistive value, it'll develop enough, whatever voltage comes out, it will force that much current to come out of the operational amplifier and drive it. That's why these things are such great amplifiers, because you can have a very small input signal with like in voltage, with almost no current going in towards the operational amplifier circuit. Yet in the output, say you amplify by a factor of 100, but then you put a very small load, a resistive value, and you can drive a ton of current, which means the power, you get a ton of power out of it. Orders of magnitude, many orders of magnitude of what you could just taking that source voltage and putting a resistor across it. So that's, yes sir.
Can you go over again why, like how you got V naught? I can get all the way to the
Okay.
part, but it V naught parts.
All right, let me erase this and just mention what's going on. This is a little messy, but I'll tell you the goal on this one is always going to be, and all of them really, is finding the voltage across these, the voltage on one of the terminals, right? So if you're wondering about if this bothers you, try disconnecting both for a second. All right? And then the voltage right here or right here is what I want, either where those X's are. Do you all follow me? So if you look at the top one, is there any way you can get that voltage based on this circuit? Well, now you gotta take a look at it. This is what looks good. What looks good is, well, this looks like simple voltage division, doesn't it? Just, yeah, but that operational amplifier circuit pushes current out. That's the thing that you don't see until you think about it, right? So you can't get that, even with that 12K, that's better to take that off, I guess, for practical purposes. Now, over here, can I get this voltage with respect to ground? Obviously, right? And since nothing flows in or out of those two terminals, that's the way I'm gonna go. I'm gonna get this voltage first, and automatically it's that voltage. Now, once I have that voltage, I have all I need, because I know I can get the current here. And in this case, the current's going the opposite direction, right? Frankly, the current's gonna go, the positive current's gonna go this way, and I would take that voltage at the X, which is V plus or V minus, and I would simply take that voltage minus 6 millivolts, the voltage on the other side of that resistor, and divide it by the value of the resistor, and I have that current. That current must flow through that 12K, because none of that current can come out of a positive or negative terminal of the input. Once I have that, I do simple, I'm just gonna simply sum the voltages from ground to V out to get the total V out voltage. How many understand this? All right? Okay.
I have a question. So it's important that the resistance going to the 12 ohm instead of the 1 ohm?
No, the resistance is known, you don't have to
I mean,
find
not the resistance, the,
current.
yeah.
You need to find the current through this resistor to get the voltage across it, right? That's what's the key, right? To get the output voltage, you need that. Okay? Got another one for me? Yes?
Jeff, you need 17.
Yeah. I want to cover one other thing here. You're gonna find operational amplifiers are so practical for a lot of things you're gonna do in the laboratory. And in this day and age, I guess nobody builds amplifiers anymore, but, or speakers, but if anybody ever wanted to, because you're engineers, you can make $1,000 amplifier, something that would be an Akai amplifier, costs at least $1,000. You can make that for probably 30, 40 bucks. The only thing you have to do is find a large transformer from an old TV or something like that, because that's what the cost is, the transformer. 1017. All right, R1, R2, R, and VI. So, the topology of this one, I think it's this. Is V1 on top in this one? You asked, whoever asked. And is this R1 here?
Yes.
And this is R2? And this is R, or what is it? Just R? And then one VI? Now, before I go through this one, how many recognize this as just about what I did yesterday, and it was something that's functionally used to add numbers? It's a summer, isn't it? The input on this one has only 2 inputs. I showed you 3. Do you remember this circuit? So if you look at this, what you'll notice is this terminal is grounded, 0 volts. That means this is 0 volts, correct, class? Far back, can you guys? Okay, if you cannot see, please put your hand up and yell at me, do something. Because I'm always concerned about the people in the background. That means these currents right here are straight to get. This is just going to be, this current I1 is V1 over R1 right here. This current I2 is simply V2 here over R2. Now, you asked about this. This is as straightforward as I can answer the question, but it should be obvious at this point. Now, once we have those currents, we know none of that current can go in the negative terminal. Clear? If you want to disconnect the connection, doesn't matter at this point. All of it goes this way. And with that in mind, I can say that this voltage right here, plus to minus, is going to be I1 plus I2 times R. So this is, actually, let me get this. I'll just call this V of R. I'm going to say V of R here is going to be the currents I1 plus I2 times R. Or, since I1 is V1 over R1, plus V2 over R2 times R That's V of R, and what would V out be, class? Yes, sir.
I just had a question real quick. If V1 and V2 are not the same, what prevents current from
They're not the
flowing?
same.
So what prevents current from flowing from V1 to V2 or from V2 to V1?
What is this?
0.
Right. Now, you asked a valid question. That's 0 volts, it never changes, follow? So if this was plus 1 volt and this is minus 1, some of that current would go there. You could think of it that way, right? But do you agree with me? I mean, I'm trying to show you that would be a thought. The current here, regardless if it's negative or positive current, is going to be V2 over R2. Do you agree with that? Now, it could be negative, right? And if it was negative, then these two numbers could actually end up being negative in their sense, correct? So actually, the value of the current is irrelevant. As long as I say positive current is considered going that way, even if the current was negative, the equations still work out right and you'll get the right answer. Okay? As a matter of fact, you can do this really easy. You can get 0 out. Suppose V1 is minus V2. Guess what? That current is that current. You got 0 current here. V out is 0. You can have that happen. All right? I'm just saying, I'm telling you things that are possible, but don't get hung up that it has to be positive current. It can be negative current as well. These are just numbers. So that would be VR, but what, my real point is, what is V out? I didn't finish the thought. Well, where do we always start from, class? Up here, still 0. This is a voltage drop, a negative sign in front of that VR. Do you all follow me on this? Raise your hands if you do. Let me know. You follow me on this, guys? Okay. Do you have any other questions pertinent to these problem sets? Because they're all the same in terms of what you need to do to get the answer. It's just analyze the voltage across one of the two inputs. Yes, sir.
Define the amplifier for a problem.
The what?
It's the thing where it's like VO over.
No, that's V out over V in. You can have only one voltage input. There's 2 voltage inputs here. You can't ask for voltage amplification because, frankly, there's 2 voltages that could be amplified. It makes no sense. Okay? Other questions? Yes, sir.
How would this problem be affected if the positives and negatives
This is a
of the
good
triangle
question.
were swapped?
Okay. In this case, they wouldn't. Now, reality, here's the real. If you want to get to an actual operational model, there would be a difference. But I'm talking about, it's in the noise difference. It's slight, very slight. But here, you gotta understand, this whole business represents tons of transistors, thousands maybe. And usually you have what's called a differential input. And basically the negative terminal is called the inverting terminal. You can read about this if you need to. Typically that's the terminal you connect the input voltage somehow through a resistor bridge to if you want the output to be inverted. The positive terminal would be the connection for the non-inverting, but this goes way beyond what you need to care about. It would still work if you put the positive up there. It would still work. It won't matter for you. Practically speaking, the plus or minus do nothing for you. They really do, but not that you need to worry about. Y'all with me, class? All right. Other questions relating to this, because this stuff, to me, is straightforward. If you spend time, you get it. I mean, how many get this stuff? Understand it? You're a holdout. You're never going to admit that you understand ever. Not you. So, man. She'll know you don't get it. You're terrible. Work harder. All right. Now, the next thing I've got to do is cover 2 types of. Sorry, I'm just having a little lighten the mood a little. I want to talk about 2 different, 2 circuits, but now with capacitors. And by the way, with a circuit like this, with operational amplifiers, with extremely few exceptions, you never use inductors. Just remember that. You use capacitors. The guy in the back of the room there can probably tell you more reasons why not to use inductors in these circuits, but never do. You can do anything with a capacitor resistor circuit that you can with an inductor resistor circuit based on the mathematical operations I'm going to be talking about, and I'm trying to actually realize integrators and differentiators. So the first thing, just pay attention. We're gonna get you your problems in a second. Draw your little op amp here and put a resistor here, and then put a capacitor here, and then call this V out and ground this terminal, and call this V in and ground this terminal, and ground the positive terminal here. Call this capacitor and this current I right here. I'll just call it I. Now, the thing that becomes critical is the current I that I'm showing there is actually equal to C dV dt. That means the voltage across this capacitor, plus to minus, Vc of t, if this is the current I, maybe I should use a small letter, the book does. It doesn't really matter, it's just a symbol. I of t is this. You all with me, class? I'm just trying to show the mathematical equations we're going to be talking about. So, if I have that, and I want the voltage across this capacitor, I'll even call it Vc of t. I simply take 1 over C, so I got to divide both sides by C, and then I do an integration. And I integrate from some point, I'm going to go from 0, let's say everything starts at t equals 0, to t of I, and it has to be prime technically, dt, and that would be my Vc of t. Now the only thing here I'm doing is restating the equation in terms of an integral, not a differential. Everybody with me on this? This is common. So by the way, this is an analog integrating circuit. This is called an analog version of an integrator. Back in the day before digital computers, they would use operational amplifier circuits to actually realize mathematical integrations in real time on computers. This is one way to do it. It's the simplest way. So if we know the current here, I, then I know the output Vc at t. You with me? Now this input can be time varying, and it will be time varying for this thing to work. So the current here, let me ask you this. My I of t here is fairly straightforward to find. If this is 0 volts, this is 0 volts. So the current there, I of t, is simply Vn of t, right, divided by R. Does everybody follow me on this? I don't mean to be moving too quickly, but you follow me. It's straightforward. All right, now if I put that in for I see that Vc of t is equal to 1 over, and because I is Vn over R, 1 over R times C times the integral from 0 to t of Vn of t dt. We can prime it. So finally, what's the output voltage? Well, the output voltage is just minus Vc of t, and you can see that V out here is equal to minus 1 over RC times the integral from 0 to t of Vi of t prime dt prime. And this thing is called an integrator. Now it has a negative sign there, and to get rid of it, you can simply put an inverter after this. Do you follow me, class? How many understand this? And you can see we realize the mathematical function of integration using analog electronics. This is the first integrators. When I was in college, they had large boards where you could literally plug in and effectively an operational amplifier, put capacitors in there of the values you choose and resistors, build an integrated part of the circuit. Then you could go to the next step and say you want to integrate not just one, but say 4 or 5 different inputs, say for a sensor of some sort. You want to do the integration and maybe you want to differentiate something. Then you have to put that stuff through a summer to get some kind of, does anybody here do anything with artificial intelligence, neural nets? Anybody at all? Well, this stuff is actually very useful for artificial intelligence because you have to get a whole lot of information from different stages and they weigh them with these functions. I won't get there now, but it's a kind of a useful approach if you want to do it with an analog version. Anyway, that was an integrator. Anybody want to take a guess at what a differentiator is? How about we switch the position of these two? That's an integrator. A differentiator does one thing different. Instead of a resistor here, we have a capacitor. And instead of a capacitor, we have a resistor. The two just shift. And now, you have a differentiator. It's an easy thing to realize, and you know, 50, 60 years ago, just before the digital age, that's the way it was done. And it worked, but very, very costly in terms of building anything that's a meaningful computer, because it's taken so much resources to do this. It's just a ton. Okay, so this is a differentiator. Now, why is it a differentiator? Remember, the key thing is, if you have a capacitor, and that's plus, that's minus, and this is the voltage across the capacitor, and this is the current through the capacitor in the positive terminal, then C times dV dt is equal to I. Can everybody follow me on this one? Now, that's ground, that's 0 volts. That means that current right there, as I'm showing you, is just C times dV dt. Can you all follow me? That's that current through there. We can call it up to, which happens to be this current. Do you agree? And this voltage will just be R times that current. Do you all follow me? I'm going to get to the point. And the output voltage will be the negative of that. So V out here would be minus, and then you're going to take that current, C times dV dt times R. So I'm going to put C times R here times V in of T dt, and that's V out. So that's a differentiator. If you wanted the actual output value to be the true differential of the input value in time, you would make the product RC equal to 1, but you may want to amplify. I'm just saying that there's amplification that also comes into this. And then if you wanted a positive value, you would put an inverter here. Do you all follow me? How many understand it? You don't understand it? What don't you understand? Let me ask you this. Can you follow me? The current through there is C dV dt. Kind of? You're going to have to take my word for it. It is. That current flows through here. R times that current is the voltage, right? The output voltage is just the negative of that. That's it. I mean, I'm trying to be as clear as I can about this. It's not rocket science in the truest